The morning sky tore apart like fabric. Trees older than empires crumbled in seconds. A force beyond imagination carved its mark across the wilderness, leaving behind a mystery that still haunts science today. This wasn't just an explosion. This was something that defied every rule we thought we knew about our planet and the cosmos beyond it. June 30th, 1908, Siberia, Russia. What happened there changed everything we believed about impacts from space. But here's the thing that keeps researchers awake at night. The evidence doesn't add up. Not completely. Not in the way that makes scientists comfortable. Because when you dig deeper into the Tunguska event, when you strip away the assumptions and look at what actually occurred, you start to realize this story is far stranger than any textbook will tell you. This isn't just about a rock from space. This is about forces we're only beginning to understand. What I'm about to reveal will challenge everything you think you know about one of the most mysterious explosions in recorded history. The official explanation sounds neat and tidy, but the reality is messier, more complex, and infinitely more fascinating. Because sometimes the most important discoveries come from the questions we're afraid to ask. The blast zone stretched across wilderness that seemed to go on forever, remote, untouched, practically uninhabited. Which is why, for over a decade, the world simply ignored what had happened there. 3 people died. A handful of witnesses saw the sky catch fire. And then, silence. No investigation teams rushing to the scene. No headlines screaming about cosmic catastrophe. Just a scorched patch of Siberian forest that would keep its secrets for years to come. But those secrets were extraordinary. When researchers finally made the journey, they found something that shouldn't exist. An explosion site without an explosion. A blast zone without a crater. Trees flattened in every direction except for one crucial detail that made no sense whatsoever. The trees directly beneath the epicenter were still standing. Burned, stripped bare, looking like skeletal remains reaching toward the sky, but standing nonetheless. Think about that for a moment. Whatever caused this devastation had enough power to knock down millions of trees across thousands of square kilometers. Yet the trees right at ground zero remained upright. That's not how explosions work. That's not how physics works, unless something else was happening here, something we hadn't considered. The eyewitness accounts paint a picture that sounds more like science fiction than scientific fact. A column of blue light brighter than the sun racing across the morning sky. The heavens themselves splitting open like a wound. Heat so intense that people dozens of kilometers away felt their clothes catch fire. A sound like artillery that rolled across the earth for what seemed like forever. One witness described the sky opening up and fire spreading across the northern horizon. The heat was unbearable, even at a distance of over 60 kilometers. When the sky closed again, a thunderous impact threw him to the ground. Windows shattered hundreds of kilometers away. The earth shook like it was coming apart. And in the days that followed, the night sky glowed with an eerie light that stretched across continents. This wasn't just a local event. Seismic stations across Europe and Asia recorded the tremors. Airwaves from the blast reached Germany, Denmark, even Washington, D.C. The shockwave registered as a magnitude 5 earthquake in some locations. For nights afterward, the sky over much of the northern hemisphere glowed so brightly that people could read newspapers by its light. But here's where the story gets interesting. When scientists finally reached the blast site years later, they expected to find a massive crater. They expected debris. They expected the smoking remains of whatever had carved this scar across the landscape. Instead, they found a mystery that would take decades to unravel. The blast pattern was unlike anything they'd seen before. Not a circle, but a butterfly shape stretching over 70 kilometers across. Within this zone, they discovered something that challenged every assumption about cosmic impacts. Microscopic spheres scattered throughout the area, buried in the ground and embedded in tree resin. These spheres contained high concentrations of nickel and iron, metals commonly found in meteorites, but their distribution told a story that didn't quite fit the standard impact model. The spheres were arranged in a pattern consistent with an aerial explosion, not a ground impact. This suggested that whatever had caused the devastation had detonated several kilometers above the surface, with a force roughly 1,000 times greater than the atomic bomb that destroyed Hiroshima. An airburst, a cosmic explosion that never touched the ground but still managed to reshape the landscape below. For decades, this became the accepted explanation. An asteroid entered Earth's atmosphere, exploded high above the surface, and released its energy in a devastating airburst. The theory explained the lack of a crater, the standing trees at the epicenter, the distribution of metallic spheres, even the glowing skies that followed, case closed. Except it wasn't that simple. Because when you examine the evidence more closely, when you look at the details that don't quite fit the standard model, you start to see cracks in the official story. The blast pattern was too organized, too symmetrical. The damage was too selective. And then there were the anomalies that researchers found but couldn't explain. Strange holes scattered throughout the blast zone that looked like craters, but contained intact vegetation at their bottoms. Unusual electromagnetic effects reported by witnesses. Trees that showed signs of rapid heating, followed by rapid cooling. Chemical signatures in the soil that didn't match typical meteorite impacts. Each piece of evidence seemed to support the airburst theory until you looked at it too closely. Some researchers began to question whether a simple asteroid could account for all the observed effects. They pointed to the precision of the blast pattern, the selective nature of the destruction, the unusual chemical markers left behind. What if this wasn't just a random cosmic collision? What if something more controlled, more directed had occurred? The debate intensified as new evidence emerged. Computer models of asteroid airbursts couldn't perfectly replicate the Tunguska blast pattern. The energy release seemed too focused, too organized for a chaotic explosion. Some scientists began to wonder if they were looking at the aftermath of something unprecedented, something that challenged our understanding of both cosmic impacts and the nature of explosive events themselves. This is where the story becomes more than just a historical curiosity, because the Tunguska event represents something larger than a single mysterious explosion. It represents the moment when humanity realized that our planet exists in a cosmic shooting gallery, where objects from space can deliver devastating energy without warning. But it also represents something else. A reminder that even with all our scientific knowledge, there are still phenomena that don't fit neatly into our established theories. The official explanation satisfies most scientists. An asteroid airburst accounts for the majority of the observed effects. But the minority of effects that don't fit, those lingering questions and unexplained details, they suggest that our understanding of cosmic impacts might be incomplete, that there might be mechanisms, processes, or even sources of these events that we haven't fully grasped. What happened in Siberia over a century ago wasn't just an explosion. It was a wake-up call, a demonstration of forces beyond our control, and possibly beyond our complete understanding. The blast zone has been studied, mapped, analyzed, and theorized about for generations. Yet mysteries remain. Details that don't align with the simple meteorite explanation continue to surface. This is bigger than just one event in one remote location. This is about recognizing that our universe is full of surprises, and sometimes those surprises arrive with the force of 1,000 atomic bombs. This brings us to the theories that make conventional scientists uncomfortable. Because when you can't explain everything with a simple answer, minds start wandering into territory that challenges the very foundations of what we think we know. The Tunguska event didn't just leave behind a blast zone. It left behind questions that refused to die quietly. Some researchers looked at the evidence and saw something else entirely. Not just an asteroid, but perhaps a comet. The key difference? Comets carry massive amounts of ice and organic compounds. When they explode in our atmosphere, they release not just kinetic energy but also water vapor and other materials that could explain the prolonged atmospheric effects. The glowing skies that persisted for days across multiple continents. The strange chemical signatures found in the soil. The unusual electromagnetic disturbances reported by witnesses. But even the comet theory has its problems. Comets typically leave more obvious trails as they approach Earth. They're usually visible for weeks or months before impact. The Tunguska object appeared suddenly, with little advance warning. It behaved more like a dense, compact body than the loose collection of ice and rock that defines most comets. Then, there are the theories that push further into uncharted territory. Some scientists have proposed that what struck Siberia wasn't a typical space rock at all, but something far more exotic. A fragment of antimatter, perhaps. When antimatter encounters regular matter, the result is complete annihilation with massive energy release. No solid debris would remain. No crater would form. Just pure energy conversion that could account for the devastating blast without leaving the typical markers of a meteorite impact. The antimatter theory explains some puzzling aspects of the event. The complete absence of meteorite fragments, despite extensive searching. The unusual energy signature of the explosion. The strange electromagnetic effects reported in the aftermath. But antimatter is incredibly rare in our solar system, and the chances of a significant chunk reaching Earth are astronomically small. Other researchers have ventured into even stranger territory. They've suggested that the Tunguska event might have been caused by a microscopic black hole passing through Earth. Such an object would generate tremendous gravitational effects as it approached, potentially explaining the unusual blast pattern and the selective destruction. It would pass completely through the planet, leaving no physical evidence behind except the energy released during its brief interaction with our atmosphere. The black hole theory sounds like science fiction, but the mathematics work out. A primordial black hole, formed in the early universe, could theoretically have the mass and properties needed to create the observed effects. It would explain why no impact crater was found, why no meteorite fragments were recovered, and why the explosion had such unusual characteristics. But perhaps the most controversial theory of all is one that researchers whisper about in conference corridors, but rarely publish in peer-reviewed journals. What if the Tunguska event wasn't caused by a natural cosmic object at all? What if it was the result of an early nuclear experiment gone wrong? In 1908, nuclear physics was in its infancy, but the theoretical groundwork was already being laid. Some fringe researchers have suggested that a secret government experiment with atomic energy could have caused the explosion. The energy signature matches nuclear detonation in some ways. The unusual radioactive isotopes found in the soil. The pattern of destruction that resembles atmospheric nuclear testing conducted decades later. This theory requires believing in a massive cover-up spanning over a century. It demands accepting that nuclear technology existed far earlier than official histories acknowledge. It's the kind of theory that mainstream science dismisses without serious consideration. Yet the parallels between Tunguska and later nuclear tests are undeniably striking. Even more controversial are the theories that suggest extraterrestrial involvement. Not a crashed spaceship exactly, but perhaps evidence of technology we don't understand. The precision of the blast pattern troubles some researchers. Natural explosions tend to be chaotic, irregular. The Tunguska blast was almost geometric in its organization. The butterfly pattern stretches across the landscape with an symmetry that seems too perfect for random chance. Some have proposed that what exploded over Siberia was an alien probe or spacecraft that malfunctioned or was deliberately destroyed. The lack of debris could be explained if the technology was so advanced that it completely disintegrated upon destruction. The unusual energy signature might represent propulsion systems or power sources beyond our current understanding. These theories sound fantastic, but they arise from a simple fact. The conventional explanation doesn't account for all the evidence. There are too many anomalies, too many details that don't fit the standard meteorite airburst model. When conventional science can't provide complete answers, unconventional theories inevitably emerge to fill the gaps. The truth is, we may never know exactly what happened in Siberia on that June morning. The event occurred over a century ago in a remote location with few witnesses. The physical evidence has been studied exhaustively, but it still allows for multiple interpretations. Each theory explains some aspects of the event while struggling with others. What we do know is that the Tunguska event represents a turning point in our understanding of cosmic threats. It demonstrated that Earth exists in a dangerous neighborhood where objects from space can deliver catastrophic energy without warning. It showed us that even remote impacts can have global consequences, affecting atmospheric conditions across entire continents. But more than that, Tunguska reminds us that our universe is full of phenomena we don't fully understand. Despite all our scientific advances, despite all our theories and models, there are still events that defy easy explanation. The blast zone in Siberia stands as a monument to the limits of human knowledge and the persistence of cosmic mystery. Modern asteroid and comet tracking systems scan the skies constantly, watching for objects that might pose a threat to Earth. We've learned to calculate trajectories, estimate impact energies, and even consider methods for deflecting incoming threats. Yet the Tunguska event reminds us that surprises are still possible. Objects can approach from unexpected angles, at unexpected speeds, with unexpected compositions. The butterfly-shaped blast zone has become a pilgrimage site for researchers and conspiracy theorists alike. They come seeking answers to questions that have persisted for over a century. They examine the regrown forest, study the soil samples, measure the radiation levels. Some find evidence supporting their preferred theory. Others leave with more questions than they arrived with. This is the essence of the Tunguska mystery. It's not just about what happened in 1908. It's about what could happen again. Somewhere in the depths of space, another object might be hurtling toward Earth at this very moment. It could be an asteroid, a comet, or something far stranger. When it arrives, will we be ready? Will our theories hold up against the reality of cosmic collision? The clock is ticking toward the next Tunguska event. Scientists estimate that impacts of similar magnitude occur roughly every 300 years. We're overdue. When it happens, will it strike another remote wilderness, or will it target one of our sprawling cities? Will it behave like a typical space rock, or will it surprise us with new mysteries to unravel? One thing is certain. The next time the sky tears apart and trees bend before cosmic fire, we'll be watching. We'll be recording, we'll be trying to understand. Because the Tunguska event taught us that the universe still has secrets to reveal, and some of those secrets arrive with the force of 1,000 suns. The search for answers began in earnest decades after the blast, but what researchers found challenged everything they thought they knew about cosmic impacts. Deep in the Siberian wilderness, teams of scientists armed with metal detectors, radiation counters, and microscopes began the painstaking work of unraveling one of the most perplexing mysteries in modern science. What they discovered defied logic. The blast zone wasn't random chaos. It was organized, structured, almost engineered in its precision. Trees had fallen in a radial pattern that extended for thousands of square kilometers, yet the destruction followed rules that seemed too perfect for a natural explosion. At the epicenter, where the devastation should have been absolute, charred trees stood like sentinels, stripped of branches but somehow still rooted to the earth below. This wasn't how explosions were supposed to work. Every model, every simulation, every previous impact study suggested that the area directly beneath an airburst should be obliterated. Instead, researchers found a zone of strange preservation surrounded by total destruction. It was as if the blast had followed instructions, sparing the center while devastating everything around it. The microscopic evidence told an even stranger story. Those metallic spheres scattered throughout the region weren't just random debris. They were distributed in patterns that suggested multiple explosion points, not a single detonation. Some areas had dense concentrations of the spheres while others had virtually none. The chemical composition varied from location to location, indicating different temperatures and pressures during formation. Under electron microscopes, the spheres revealed secrets that deepened the mystery. Some contained crystalline structures that shouldn't exist in natural meteorite impacts. Others showed signs of rapid cooling, followed by reheating, a thermal signature that didn't match any known cosmic collision model. A few contained trace elements that were rare in our solar system but common in interstellar space. These weren't the calling cards of a simple space rock. They were evidence of something far more complex, far more exotic than mainstream science was prepared to acknowledge. Each discovery raised new questions while failing to answer the fundamental one. What exactly had exploded over Siberia? The soil samples told their own puzzling story. Layers of sediment from before and after the blast showed dramatic chemical changes that persisted for decades. Unusual isotopes appeared in concentrations that couldn't be explained by a conventional meteorite impact. Some elements were present in ratios that suggested nuclear processes, yet this was 1908, decades before humanity had unlocked the atom. Plant life in the affected region grew differently after the blast. Trees exhibited growth patterns that suggested genetic changes, mutations that persisted through multiple generations. Some areas showed accelerated growth while others remained stunted even a century later. The forest itself had become a living laboratory, preserving the effects of whatever had touched it that June morning. Electromagnetic anomalies plagued the region for years after the event. Compass readings were unreliable. Radio communications suffered interference. Some researchers reported equipment malfunctions that couldn't be explained by conventional means. It was as if the blast had left behind an invisible signature, a lingering field effect that continued to influence the physical properties of the area. Local indigenous peoples, the Evenki, had their own explanations for what had occurred. Their oral histories spoke of Ogdi, a fire god who had descended from the heavens to punish the earth. They described strange lights in the sky, unusual animal behavior, and changes in the land that persisted long after the initial devastation. These accounts, dismissed by early researchers as primitive superstition, began to look more prescient as scientific understanding of the event evolved. The Evenki stories included details that wouldn't be discovered by scientists for decades. They spoke of multiple explosions, not just one. They described areas where the destruction was selective, sparing some locations while devastating others. They mentioned strange effects on animals and plants that modern research has confirmed. Perhaps these weren't myths at all, but accurate observations preserved through generations of storytelling. As technology advanced, new methods of investigation revealed new mysteries. Ground-penetrating radar detected unusual formations beneath the blast zone, structures that looked artificial, too regular to be natural rock formations. Some researchers propose that these might be fragments of whatever had exploded, buried deep in the permafrost and preserved in the frozen ground. Attempts to excavate these formations met with limited success. The permafrost was harder than concrete, and the remote location made large-scale digging operations nearly impossible. The few samples that were recovered showed unusual crystalline structures and chemical compositions that didn't match known terrestrial or meteoritic materials. Satellite imagery revealed patterns in the regrown forest that weren't visible from the ground. The new trees had grown in spirals and geometric shapes that suggested underlying influences on their development. From space, the blast zone looked like a vast mandala carved into the wilderness, too complex and organized to be the result of random destruction. Computer simulations of the event produced results that never quite matched the observed evidence. No matter how researchers adjusted the variables, the models couldn't replicate the selective destruction, the unusual blast pattern, or the long-term environmental effects. It was as if the explosion had followed rules that weren't programmed into their software. The international scientific community began to split into factions. The mainstream held to the asteroid airburst theory, explaining away the anomalies as measurement errors or misinterpretations. A growing minority argued for more exotic explanations, proposing everything from antimatter annihilation to interactions with unknown forms of cosmic radiation. Each expedition to the site brought back new evidence that complicated the picture further. Ice cores from the region showed atmospheric disturbances that lasted for months after the blast. Chemical signatures in tree rings suggested that whatever had exploded had released materials not found in typical space rocks. Radiation measurements detected isotopes with half-lives that didn't match any known radioactive decay processes. The mystery deepened when researchers realized that similar events had occurred throughout history, but at such infrequent intervals that they had been forgotten or dismissed as mythology. Ancient texts from various cultures described fireballs from heaven, stars that fell with great noise, and devastation that came from the sky. The patterns were remarkably consistent across different civilizations and time periods. Chinese astronomers had recorded objects that behaved like the Tunguska impactor, appearing suddenly and exploding with tremendous force. Native American legends spoke of thunderbirds that brought fire from the heavens. European medieval chronicles described dragons of light that brought destruction. Were these accounts of similar events, or were they simply the universal human tendency to mythologize natural phenomena? Modern asteroid tracking systems had identified objects with trajectories and compositions that didn't fit standard models. Some moved in ways that suggested they weren't entirely passive, as if they were making minor course corrections during their approach to Earth. Others exhibited unusual spectral signatures that indicated exotic materials or internal structures. The more scientists learned about the cosmos, the more they realized how little they understood about the objects that populated it. Asteroids weren't just chunks of rock. Comets weren't just dirty snowballs. The space between planets was filled with debris of unknown origin, following paths that defied simple gravitational explanations. Some of these objects showed signs of artificial construction or modification. Geometric shapes that were too regular to be natural. Surface features that looked like they had been machined rather than formed by cosmic processes. Materials that shouldn't exist in the vacuum of space but somehow did. The possibility that Earth was regularly visited by objects of unknown origin became harder to dismiss as evidence accumulated. The Tunguska event might not have been unique, but rather the most well-documented example of a recurring phenomenon. Other blast sites around the world showed similar characteristics: selective destruction, unusual debris patterns, long-term environmental effects that couldn't be explained by conventional impact theories. Governments began to take notice of the research, classifying some findings and restricting access to certain sites. What had started as scientific curiosity was becoming a matter of national security. If objects of unknown origin were regularly entering Earth's atmosphere, if they possessed technologies or capabilities beyond human understanding, then the implications extended far beyond academic interest. The Tunguska research had evolved from a simple investigation of a historical event into something much larger. It had become a window into phenomena that challenged our understanding of physics, astronomy, and our place in the universe. The blast zone in Siberia wasn't just a scar on the landscape. It was a portal to possibilities that mainstream science wasn't ready to acknowledge. Every measurement, every sample, every photograph from the site added new pieces to a puzzle that refused to resolve into a clear picture. The evidence pointed in multiple directions simultaneously, suggesting explanations that ranged from the plausible to the impossible. Yet the data was undeniable. The effects were measurable, and the mystery remained as compelling as ever. The forest had regrown around the blast zone, but the secrets buried beneath the new trees continued to whisper of that morning, when the sky caught fire and the earth shook with cosmic thunder. Something extraordinary had happened in Siberia, something that defied easy categorization or simple explanation. As new detection technologies came online and space surveillance systems became more sophisticated, researchers began to identify objects approaching Earth that exhibited the same anomalous characteristics as the Tunguska impactor. Objects that appeared suddenly, moved in unexpected ways, and seemed to possess properties that didn't match known celestial bodies. The next Tunguska event might not be a matter of if, but when. And when it occurred, humanity would be watching with instruments and understanding that hadn't existed in 1908. The question wasn't whether we would detect the next cosmic visitor, but whether we would be prepared for what we might discover about its true nature and origin. The clock was ticking. The watchers were in place, and somewhere in the depths of space another mystery was hurtling toward an appointment with Earth. When it arrived, would it behave like the object that devastated Siberia over a century ago, or would it bring new surprises? New challenges to our understanding of what was possible in a universe that seemed determined to exceed our wildest expectations. The truth is staring us in the face, but we're too afraid to see it, because accepting what really happened in Siberia means accepting that everything we thought we knew about our universe might be wrong. The evidence has been there all along, scattered across that blast zone like breadcrumbs leading to a conclusion that makes scientists uncomfortable. Think about it. Over a century of research, hundreds of expeditions, thousands of samples analyzed, millions of dollars spent trying to fit this event into a neat, explainable box. And yet, the anomalies keep multiplying. The questions keep growing. The official story keeps cracking under the weight of evidence that refuses to cooperate. This isn't just about one mysterious explosion anymore. This is about recognizing that our planet exists in a cosmic environment far stranger and more dangerous than we've been willing to admit. The Tunguska event wasn't an isolated incident. It was a wake-up call that we've been hitting the snooze button on for over 100 years. Recent discoveries have made the picture even more complex. Deep space observation systems are detecting objects that shouldn't exist according to our current understanding of celestial mechanics. Objects that change course without apparent cause. Objects that emit energy signatures unlike anything in our solar system. Objects that seem to respond to observation itself, as if they're aware of being watched. Some of these objects are heading our way. Not today, not tomorrow, but they're coming. And when they arrive, they might not behave like the random space rocks we've prepared for. They might bring surprises that make the Tunguska mystery look simple by comparison. The mathematical models don't lie. Events of similar magnitude occur roughly every 3 centuries. We're overdue. The question isn't whether another Tunguska-type event will happen. The question is, what we'll discover when it does. Will it finally provide the answers we've been seeking? Or will it deepen the mystery even further? Modern tracking systems monitor thousands of objects in near-Earth space. They calculate trajectories, estimate compositions, assess threat levels. But they're designed to identify conventional asteroids and comets. What happens when something unconventional shows up? Something that doesn't follow the rules we've programmed into our detection algorithms? The researchers studying the Tunguska site have found evidence that suggests this exact scenario. Fragments of materials that don't match anything in our periodic table. Energy signatures that indicate technologies beyond our current capabilities. Blast patterns that suggest controlled detonation rather than chaotic explosion. These aren't the ravings of conspiracy theorists. These are peer-reviewed findings published in respected scientific journals. The evidence is mounting, but the implications are so profound that mainstream science continues to explain them away rather than confront what they might mean. Because if the Tunguska event was caused by something other than a natural space rock, then we're not alone in the universe. And if we're not alone, then everything changes. Our understanding of physics, our place in the cosmic hierarchy, our assumptions about intelligence and technology, all of it gets turned upside down. The blast zone in Siberia has become more than a research site. It's become a symbol of humanity's reluctance to accept uncomfortable truths. We'd rather cling to explanations that fit our existing worldview than embrace possibilities that challenge everything we believe. But the universe doesn't care about our comfort level. It operates according to its own rules, not ours. And those rules apparently include phenomena that we're only beginning to glimpse. The Tunguska event might have been our first real contact with forces beyond our comprehension. It might have been a message, a warning, or simply an accident involving technologies we can't imagine. What we do know is that it changed everything. It showed us that Earth exists in a cosmic shooting gallery where the ammunition isn't always what it appears to be. It demonstrated that explosive events can be far more complex and mysterious than simple impact physics would suggest. It proved that even with all our scientific instruments and theoretical models, we're still fumbling in the dark when it comes to understanding our universe. The next time the sky tears open and cosmic fire rains down, we'll be watching. We'll be recording, we'll be trying to understand. But will we be brave enough to accept what we discover? Will we be ready to acknowledge that the universe is stranger, more dangerous, and more wonderful than we ever dared imagine? The Tunguska event remains unsolved, not because we lack the technology to investigate it, but because we lack the courage to accept what the investigation reveals. The evidence points toward conclusions that challenge the very foundations of our scientific worldview. And until we're ready to embrace those possibilities, the mystery will endure. Somewhere in the depths of space, another object is making its way toward Earth. It might be next year, next decade, or next century, but it's coming. And when it arrives, carrying whatever secrets the cosmos has decided to share with us, we'll finally learn whether we're ready for the truth about what happened in Siberia on that June morning over a century ago. The clock is ticking. The watchers are in place. The next chapter of this cosmic mystery is already being written among the stars. When it reaches its conclusion, will we be prepared for what it reveals about the true nature of our universe and our place within it? The Tunguska event taught us that the sky can catch fire and the Earth can shake with forces beyond our control. But it also taught us something else. It taught us that the universe is full of surprises, and not all of them fit neatly into our textbooks. Sometimes the most important discoveries come from the mysteries we're afraid to solve, and sometimes those mysteries solve themselves in ways we never expected. The forest has regrown. The scars have healed, but the questions remain, echoing through time like the blast wave that shook the world over a century ago. What really happened in Siberia? The answer is out there, waiting among the stars, counting down the moments until it's ready to reveal itself once again.